Hi, welcome back. In this video, I'll be installing the BTT SFS sensor to Ender 3 with Sprite Extruder and K3D dual part cooling system. So let's start with the wiring diagram. Now let's see how we can wire the SFS sensor to Manta M5P board. Here I have min 1, min 2, min 3 and min 4 ports. Min 1 and 2 are connected to X and Y end stop. Min 3 is empty. Min 4, I'm using my existing sensor, which I'm going to replace with SFS sensor. Now let's see the SFS wiring. So if you see here, we have red and blue, which is for the normal filament runout sensor. So the red one is for 3.3 or 5 volts, and the blue one is for the signal. Now this one will connect to pin 4. And the above that you have motion sensor, which is green and black. The green one is for the motion sensor and the black one is ground, and this will connect to min 3 port. Now if you look at the connector orientation and the housing on the board are matching. So when you connect as it is the connector to the M5P board, they will connect as it is. The red one will go to 5 volts and the blue one will connect to PC2. And for the motion sensor, when you connect that to min 3 port, the green will connect to PC3 and the black will connect to ground. So we don't have to swap the wires for the connectors. Now let's connect these wires. So one side you have this connector where you have 4 wires. On the other side it is terminated with 2 connectors, 2 wires each. So this is for the normal. So this wire is for the normal filament sensor and this is for the motion sensor. So this one I will replace with my existing, which is at min 4. So this is the one I will replace, and this one I will connect to min 3. So now the wiring is done. Now let's connect the sensor. So you have this wire here and the sensor. It goes in here. So as soon as you connect, a red light will come on. Sometimes the blue will also come on. To insert the filament, you can do it either from this side or this side. So you can give a slight push, the filament will go in, red light goes off. The other way is you have to pull this knob downwards away from the connector. So pull it down and you can easily slide in. So that is how you insert the filament. Then what I have noticed, this is just a dummy test. I have not done any actual prints. Now there should be, if the filament is not moving, the blue light should stay steady on, which I don't see. So I will do the actual test print and see. So I have started a dummy print. There isn't any filament installed in the hot end, and the sensor I have just placed like this. I've put a filament inside, and this one is just dangling like this. So I will hold it like this and trigger slow movement and then stop once the print starts to see whether the motion gets triggered or not. So the printing will start now. I will leave this sensor with this filament inside just over here to see what happens. So the encoder sensor has triggered and has gone to the pause location. Now I'll resume and keep moving the filament inside. So I'm manually moving the filament. It is printing, and now I'll stop, and the encoder sensor triggered. So now we'll test the switch sensor. So resume. And the switch sensor is triggered. So the filament seems to be doing its job, but I'll do the actual print and see. Before we mount, let's look at the SFS-Sprite adapter CAD view. So this is the part that we need to print, and it should be printed in this orientation. Bottom over here, this is a brim, built-in brim that I have added. This is required for this part to print properly. So if you don't add this brim, then in the slicer, we have to make sure that we add the brim. So that is why I've added over here. So if you don't have this brim, so let me suppress this. So if you don't have the brim, look over here. This is the only contact area to the bed. This and this is the only contact area to the bed, which is not enough. This part will knock off. It will fall while printing. So that is why I have added this brim in order to increase the contact area. Now let's look at the printing orientation for the bracket. We'll load the model. So it will be loaded like this. You need to print this part facing down. So this way you can click on this auto orient button. So this will make it flat down, and then you can print it. No need for adding support. This will print fine. Now let's see the mounting process. So here I have the actual sensor, M3/6, 3 screws, PTFE board and tube connector, and the remaining things that comes with the sensor. So these I will not need. So I will need only one of these and the three M3/6 screws. So if you want, you can use both the connectors, one from the top side where you insert the filament, and one on the bottom side where the filament exits. From the top side, I don't see it's necessary. I don't think it is necessary, so I will only install on the bottom side. So while installing the sensor, the wire connector should be on the right side and the screws facing towards me. So having in this orientation, this will be the top side and this will be the bottom side. So I'll install this on the bottom side. On the right side, I have this bracket, then the SFS-Sprite adapter and the PTFE tube. This PTFE tube is 41.5 mm in length. So this needs to be installed over here. Before that, we'll mount the bracket. So it should be mounted like this. Now we'll install the PTFE tube. Push it right inside, and then you have to install this adapter. Orientation of this, there are two flat side. So this will go in this way. So let's say sensor is mounting this way. The mounting side to the Sprite Extruder is on my right, and the PTFE tube or the exit side is on the bottom. So this one will go in this orientation. So you have the flat side facing away from me and the second flat side facing to the left side of me. So it should go this way. So this is how you need to install it. You can say the flat side over here, and this side is the flat side. So flat side facing away from me and to my left. So now next we'll mount it on the Sprite Extruder. To mount the sensor, we need to remove these screws, this and this one. These are M3/6. Now you cannot use both the screws. One screw you can use, that is over here. Here M3/6 will work, but for this one over here, we need to replace it by M3/8. So make sure that the PTFE tube is gone right inside, and then you take M3/6 and use it in this hole, and then you can tighten this, and then M3/8 over here, and then connect the wire Now let's load the filament. It's pretty easy. So you just give it a slight push, it will go inside, and right until the lever over here. Then just push the lever down. You have to pull it down like this, and then give it slight push, so it will go inside. Then you turn on the printer, heat the hot end, and load the filament. Now let's go to Klipper and do the required configuration for the sensor to get it working. As of recording this video, I am using Klipper version 0.13.0-375. Log into your Klipper interface. I use mainsail, then go to machine. The configuration that I'm showing here can be inserted directly into printer.cfg file. You don't need to create a dedicated configuration file, but you can do that by clicking this create button over here. Click on this button, give it an appropriate name .cfg, and then click on this create button. I have created this file over here, BTT SFS.cfg. Now let's open this file. In this file, you have three sections. The first one, this is the normal filament runout section. Then this one is for the filament motion section. And this one is for the delay G code, which will be executed when Klipper starts. Now let's see the first section. In this, you have to define the pin where the runout sensor is connected. Pause on runout, you have to set this to true. If you set this to false, then under runout G code, you need to define pause G code. In either case, you have to ensure that pause underscore resume is defined in your printer.cfg file. Then you have filament motion section. You have the switch pin where the motion sensor is connected to. Then detection length. This detection length is the amount of filament that must be moved. If it doesn't move this much of length, let's say 7 mm, then the motion sensor will be triggered. Event delay. Events triggered during this time period will be silently ignored. So let's say if there are 3 events triggered during this 5 seconds, then those 3 events will be silently ignored. Then you have extruder. This is what you need to define here, where this motion sensor is associated to. I have only one extruder, so that is what I have defined here. Pause underscore runout, same as above. Then I have this unload filament defined over here and here. So as soon as both these sensors are triggered, the runout sensor and the motion sensor, then unload filament will trigger. And then you have this section. So this will be executed at the start of the Klipper. What I'm doing here is I have this encoder sensor, the motion encoder sensor defined over here. So when the Klipper starts, I make sure that this sensor, motion sensor, is set to false. I'm disabling the sensor. It is required to avoid false triggering. Otherwise, while doing any maintenance work or when you start the print, when you run your purge line amount, that time if you have this enable, then the motion sensor will be triggered and unnecessary it will pause. So to avoid that, I'm using this particular parameter. Now let's save and close. Do not save and restart. So we have to include this file. So you can save this file. Then go to your printer.cfg. And over here, I have included mine. So enter this text or this particular line and then click on save and restart. So this will save and restart your printer. Next, I have this macro file defined here in my printer.cfg file. The unload filament macro is mentioned in this file. So we'll see this file. So let's open this file over here. And then on the right side, you will have unload filament. Just click on this one. It will take you directly there. Here. Now in this, what I'm doing is set some few parameters. And then I extrude 3 mm of filament, set it to 0, and then I unload 18 mm of filament. So it will reverse back 18 mm. So that's on the unload filament. Now let's look at the start print macro. At line number 11, I am setting the encoder sensor to 0. That is, I'm disabling this encoder sensor. And just before the start of the print, I am re-enabling the sensor. This is required for me to set or to disable this sensor at the start. That is due to the line purge that I have in this configuration here. So this says Z to set at 0.28 height, and next line it says Y go 130 extruding 15 mm of filament. So here there is no problem, but when it comes to this line, I am saying Y go 15 extruding 1 mm of filament. So the problem comes here. If you look at the detection length, I have set to 7 mm, which means this at this step the extruder is not moving 7 mm. So it is less than 7 mm, so the filament gets triggered since there is no move. That is why I need to disable over here and then re-enable over here. So we have to find the right balance to set the detection length. This is something that we need to do some trial and error to find the right value. Configuration shown here will not work for your printer. Take this as a sample configuration and tune your printer accordingly. Setting this value too low will give you too many false events, and setting it too high is also not good because you will miss when there is actual filament movement problem. A value between 5 to 10 is a reasonable value to start. To find out, what you can do is find out what is the maximum move that you do without extruding the filament, and that value you can set over here. So in my case, if you look at the purge line that I was doing earlier, I'm doing a purge line or moving from Y130 to Y15 and extruding only 1 mm of filament, which falls in the movement range. So it triggers that value. So that is why I was disabling at the beginning. And during my normal print, what I found is value between 5 to 10 is working for me. Event delay, the default value of 3 seconds is good enough. I didn't find much difference by increasing this value. So this value of 5, I will revert back to 3. So that's all for this video. Thank you for watching. Do like, share and subscribe. God bless and stay safe.